Welcome back, my dear math monitor students. In my part 4 polynomial unit, we are learning factoring quadratic trinomials. We'll start from the basic that you must have done in your algebra 1, but I'm going to start from the scratch. Okay, before I go by the factoring, I want to tell you the first step you must be doing no matter what you are. If you are working on factoring quadrilateral, yes, you must check for GCF. And what is GCF? If you say, for example, if your equation is something like this, minus 6x minus 56, if you see each term is a multiple of 2, so there is a GCF of 2. You can take out that 2, so it will be x squared minus 3x minus 28. So this is called the GCF. This is the GCF. So whenever you are doing factoring, no matter you are doing a trinomial or any other polynomial, always you must check the GCF. That is the first rule. Second rule, check if it is that you are doing quadratic trinomial, check for perfect square. And perfect square, as of now, some of you might not be knowing what is a perfect square. By the end of this video, you will learn what is a perfect square. So then onward, your second step will be check for perfect square, right? For now, we will not do this step. So third step is, of course, factoring. So right now for beginning, we will do check for GCF and we'll do factoring. Once you learn perfect square, your second step is to check for perfect square. Okay, so let's start with our basic trinomial factoring. This is my first question. What is happening here? X squared minus 3x minus 28. I hope it is visible. Okay, here in this case, the last term and the leading coefficient. If there is no number in the leading coefficient, means there is 1. There is 1, invisible 1. So what is the product of these two, leading coefficient and the constant term? Product is negative 28. The center term, the x term, the coefficient of the x is the sum of two numbers. What do I mean by that? That means there are two numbers whose product must be negative 28 and sum must be negative 3. How can you get those two numbers? If you are smart enough and you have learned this before, you must be knowing it. If not, you can start from the scratch, like the tree factoring. 2 times 14. By any chance, if you add or subtract 14 and 2, will you get negative 3? Nope. So then move on. Do more factoring. 2 and 7, right? Multiply this 2. 2 times 2 is 4. Now, is there any way this 4 and 7, if you add or subtract, you will get negative 3? Yes. If you do positive 4 and negative 7, positive 4 and negative 7, you will get negative 3. And if you multiply them, you will get negative 28. So you got your numbers. So your factor is directly those numbers as long as the leading coefficient is 1. So your answer is x plus 4 and x minus 7. You got your first answer. Not that hard, right? I hope you guys got it. Okay. If you want to recheck the video, that portion of the video, double check. Maybe I'm going a little faster. So take your time to register and then move on to the next question. Try to do the next question by yourself. If not, let's do it together. Now, what is the factor? What is the product? I'm sorry. So what is there? There is 1, invisible 1. 1 times 6 is 6. So here in this case, the product is 6. What is sum? Sum is negative 5. Now, what are the two numbers whose product is 6 and sum is negative 5? You can factor. If you are smart enough, you know that, oh, 2 and 3 can give me 5. To get negative 5, I must have both of them negative, so that the product will be positive 6, right? So what are my factors? You got it. So it is x minus 2 and x minus 3. Yay, you guys are getting it. Now the next one. Let's see this one. You can hold the video and try to do this one. And then check with my answer. What is the product? Yes, 5. You are right. What is the sum? 6. That's right. Now the product is 5. What is the 5 is multiple of, what are the multiples of 5? Nothing, just 1. So 1 times 5 is 5. So that means you can see it could be 1 and 5. And if I add them, I will get 6. If I multiply them, I will get 5. So it's so simple. So I got the numbers as x plus 1 and x plus 5. 5 times 1 is 5. 5 plus 1 is 6. Sum and product both is holding good. Let's see more question. Okay. So here the product is answer 16. Yes, sum is 8. So what are the two numbers? You know the two numbers directly, you can answer it. What are the two numbers whose sum will be 8 and product is 16? Yes, 4 times 4 and 4 plus 4 is 8. So it is x plus 4 and x plus 4, which means x plus 4 is repeating. When two numbers repeat, we put it as a square. So this is a perfect square. We'll come back to perfect square again later, and we will analyze how the perfect square works. Okay, one last question. You want to try by yourself? Pause the video and do it by yourself. So what is the product? Negative 22. What is the sum? 9. So take the factors of 22, which was 2 and 11. And is there any way I can get 9? Yes, you can get 9. If you subtract 2 from 11, you will get 9, and their product is negative 22. So you got the numbers. So answer is x minus 2 and x plus 11. Right? Okay. Let's move on to something else. Like now the leading coefficient is not anymore 1. See, the leading coefficient is not anymore 1. So what will we do here then? Don't worry, it's not that bad. So the product, now this time the product is 2 times 6, 12. This is an easy question with lower numbers, smaller numbers, so it's easy to do the product. Going forward, when you'll see these numbers are big, you do not have to do the product because you will need calculator, you will take time. Leave those numbers as is. As is means 2 and 6, because anyways you are going to factor it, right? Okay, what is the sum? Sum is 7. Now, how will I get? I have one factor 2. Let me check. This is 2 and 3. Let me check. This one will become 4 and 3. 4 times 3 is 12. 4 plus 3 is 7. You got the number. How will I write it here? I will not write it there directly. I will write it here. As is, x plus 4, x plus 3. But this is not the right answer because there is a leading coefficient. There is an extra effort here. You have to divide the leading coefficient, whatever the leading coefficient, on this number. Like this. So what will be this become? X plus 2. Your answer is x plus 2. Do not show this step here. Your teacher might not like it because this is not a traditional way of solving trinomials, quadratic trinomials. So some teachers might not understand what is going on. You can directly write the answer. And if you have to show the steps, if you're in Algebra 1 or 7th grade math, then it's the traditional method is different. I will make that is the grouping method. I will make a different video on that. This is for Algebra 2 SAT kids who need the answer just upfront. Okay, so what is the next factor? Next factor, this 2 will come here. So it will be 2x plus 3. That's it, 2x plus 3. You got your factor, it's not that bad. X plus 4, x plus 3, divide by the leading coefficient. Simplify it, so x plus 2 and 2x plus 3. Okay, you can hold the video, check that portion of the video, and then pause the video, try to do this question by yourself. Okay, the next question is product is 2 times 21. I will not take the product, I'll just keep it like this. Sum is 13. So let me, 2 is already there. I will factor only 21. 2 is already there. So I'll factor 21. 21 is 3 times 7. If I multiply this 2, 3, 6 and 7. Sometimes you have to cross check, okay? You can check this 2 and this also. For my question, this is easy. I can check 2 times 3 is 6 and 7. And if I add them, I'm going to get 13. So that's it. I got my numbers. So what will be my answer? X plus 6 and x plus 7. But this is not the final answer. Why? Because the leading coefficient is not 1. What is the step? You have to divide by the leading coefficient here. So if you divide this, what you are going to get? X plus 3. So it is x plus 3. What you are going to get? This, bring the 2 here. So it will be 2x plus 7. Not that bad, right? So lots of kids get scared of it, but it's not that bad. Okay, let's try this again. You can pause the video, do it by yourself, and then check my answer. So what is the product? As I said, I will not write the product. I will just leave it as is. Sum is what? Negative 3. So what are the two numbers? I already have 2. I have to factorize 35, which is what? 7 and 5, 5 and 7, whatever you say, 5 and 7. Let me check. 2, 5, 10 and 7. 10 and 7. Can I get negative 3? Yes. If I do negative 10 and positive 7, I will get negative 3. So I got my factors. What are my factors? X minus 10 and x plus 7. What is the catch here? Again, you have to divide. This is not the final answer. Divide by 2, divide by 2. This becomes 5. So it is x minus 5 and this is 2x plus 7. 2x plus 7. If you are watching for Algebra 1 math, then your teacher might want you to show the steps. How did you get this factor? So that is a different way. That is a grouping method. I will make a separate video on that. This particular method, I'm solving it for Algebra 2 kids, Algebra 2 onwards and SAT kids. So they need the answer directly. Okay. So I think this is pretty much it for the factoring quadratic trinomial. Now we'll move on to perfect square. Yes, as I promised you guys that I will teach you how to figure out the perfect square. How to figure out the perfect square. What is the method of finding the perfect square? Here. Focus completely here and you will get it. Check whose square is this. I hope I'm showing the, yeah. Whose square is this? X. Whose square is 1? 1. If you multiply this 2 along with 2, number 2, what will you get? X times 1 times 2 is 2x. Which is the middle term? Which is the middle term? If that is so, that means this is a perfect square of x plus 1 whole square. This is a perfect square of x plus 1 whole square. Perfect square of x plus 1 basically. So you can do by the factoring method and you will see the answer is this. Let's try some more question. But as I told you, no matter what kind of factoring you are doing, first you have to check for GCF. Is there a GCF possible? Yes, there is a GCF possible. All the terms are multiple of 3. So take out 3. What do we have here? 3, 10, and plus 25. Now let's check whether, as I said, second step for factoring, if it is a quadratic trinomial, check whether it's a perfect square or not. How will you figure it out whether it's a perfect square or not? Whose square is this? N. Whose square is this? 5. If I multiply this 2 with 2, 5n times 2 is 10n, which is the middle term. That means this is a perfect square of this. If you ask me from where you are getting this positive sign, I am getting this positive sign from this first positive sign. We'll do some question with negative also. So this guy is factored like this. So if you know perfect square, you do not have to do all the drill of factoring. You can directly get the answer. Let's check this one. See, there is a negative sign. So, and there is no GCF. Let's check for the perfect square. Check. Whose perfect square is this? 9a square. 9 is the perfect square of 3 and a. Whose perfect square is this? 5. And if I multiply this 2 by 2, 3a times 5, which is 15a times 2 is 30a, which is same as the middle term. Means this is a perfect square of what? Of this. Now the middle term makes more sense. This sign will come here. So this is a perfect square of 3a minus 5 whole square. There is another question and okay, I thought of leaving it up to you guys to solve it, but I'm doing it for you. You can pause the video, do it by yourself and then double check. Okay, what is going on here? We can take a GCF of 5, so it will be 16p square plus 40p plus 125 divided by 5 is 25. Now second step, GCF step is done. Second step, check for perfect square. Whose square is this? 4p. Whose square is this? 5. If I multiply this 2 by 2, 4p times 5 is 20p times 2 is 40p, which is same as the center term, that p term. So this means this is a perfect square of this. You can pull out some perfect square worksheet and work by yourself. And if you're my existing students, you can reach me out. I'll give you some extra worksheet on that. Okay. Now, the last thing, that is the advanced. This particularly is for sometimes pre-cal honors or pre-calculus honors, algebra 2 honors, or advanced algebra 2, or for SAT. So looking at this is not quadratic. Looks like quadratic, but this is not quadratic. But it's a trinomial. We can convert it into quadratic. So what is the catch here? How can we do this? X to the power 4 can be written as x square whole square. If you know your exponents rule, This is this. If you don't know the exponent rule, very soon I'm going to upload my exponent videos. You can go over that one. So I did x to the power 4 as x square square. Now think about it. What if I replace x square by any other variable? I'm replacing x square by any other variable, like your choice. Pick your name's first letter. I will take it as lower a. So I will replace x square by a. So a square, this x square is replaced by a square minus 9, x square is replaced by a plus 14, and this is a normal quadratic expression which you can factor easily. What is the product? Product is 14, and 14 means 2 and 7. If you put negative to both of them, you will get the factor as a minus what, 2 and a minus 7, but there is no a in the question. Our question has x squared. Now the final answer is replace a by x squared. I think I do not have much space. I will use the different color not to mix it up. So what is a here? X squared. My final answer is x squared minus 2 and x squared minus 7. What did I do here? I just replaced a by x squared. That is my final answer. Okay, let's try some more questions here, which are like to the power 4. By this time, if you check that portion again, you will understand what I did. I did this step, minus 11x squared plus 10. Some teachers do not like this substitution method. They just want you to do it directly. Yes, you can do it directly. It doesn't matter. Consider in your brain that this is a or some other variable, like 3b squared minus 11b plus 10. So what is the product here? 30. And what is the sum here? 11. Check the product, 5 and 6, right? 5 and 6 gives you 11 if I put both of them negative. So my answer is x squared minus 5 and x squared minus 6, because now that is x squared. But this is not my final answer because the leading coefficient is 3. So you have to divide by the leading coefficient on both of them. So this 3 will come here. So your answer is 3x squared minus 5. That is one of the factor. The other factor will be, you can reduce this, which is x squared minus 2. X squared minus 2. Okay, let's do these two questions. I'm leaving it for you. Extra work. You can try by yourself and check your answer. The last and the one which normally appears in SAT and some advanced algebra kids. What to do here? Okay, it looks crazy, but it's not. Okay, I'm going to write the same question as x to the power what? N squared plus 13x to the power n plus 6. Okay, so now again the same thing. If you see, x to the power n is like a variable, any variable, p. So it's like 5p squared plus 13p. I'm not writing the variable again, as we understand how to use it. So now what is the product? Product is 30, and sum is 13. What are the two numbers you get? 33 and 10, right? You will get 30. So your answer is x to the power n plus 3. I hope it's visible. And x to the power n plus 10. But there is a leading coefficient, so divide by 5, divide by 5. 5 will go there. Answer is 5x to the power n plus 3. And this will be, this is gone, which is 2. So x to the power n plus 2. I hope you guys got it. This is all for quadratic trinomial. There will not be any other crazy questions. They will be all similar. Maybe there will be 2 variable question which I have not gone over here, but yeah, I think rest you can get it. So yes, if you like my video, you can share, subscribe, and have a great day, guys. Thank you.